Hi, everyone. This is Ryan Lewis, and welcome to another episode of Training Data, the podcast series from CosmiQ Works that is arguably the most rich and compelling episode available anywhere on geospatial analytics. We're really excited today to be launching a one more time, part episode series with our friends from Azavea. And we've been circling this pod for a while now, and it's kind of like the Top Gun sequel, which I'm just going to make a claim right now. It's Oscar worthy just from the trailer, where we've looked at the schedule, we tried to get on it, and then we just couldn't get everyone in the same room. And now the stars have aligned, and everyone is here. And so first, I want to welcome our guest. First, Rob Emanuele. He's the VP of Research at Azavea, and then the person known on Twitter as the mouth of Morrison, the one, the only, Joe Morrison, Azavea's raster foundry product specialist. Welcome to the show, guys.
Thanks for having us.
Yeah, thank you so much.
And then we have CosmiQ's, not really sort of the Twitter savant and training data veteran, Nick Weir. Welcome back, Nick.
Thanks. I'm here to keep you honest.
I wish you the best of luck in that task. May the odds be ever in your favor. All right, as mentioned, so we're dividing this episode into three separate parts. So first, today, we'll be discussing how emerging AI technologies will enable mapping in different geospatial applications. And I think there's a lot for us to dive into. We've talked about this topic before on training data, and we're excited to have that discussion in the context of all the cool things that Azavea has done. For future episodes with these guys, we'll also be diving into the utility of pre-training AI models and multi-spectral satellite imagery data, as well as having a pretty frank discussion about what it means to stand up a business around open source software. So a lot of good material. So make sure to subscribe to this podcast and stay up to date when we release those pods. So let's dive into the first one, guys. All right. So we're talking today about how AI and machine learning can impact geospatial. This is something that is increasingly coming up across our domain, from things that we see in hot OSM all the way to things that are happening in the government sector. But let's start at the beginning as it relates to Azavea. How did you guys get started looking at these types of technologies? Was this something that was sort of natural in your product course? Because I don't think everyone knows this. You guys started back in 2001, so you've been at this way before anything like deep learning or TensorFlow existed, which almost seems impossible today.
Yeah, so we've been a geospatial software firm for as long as you had mentioned. Starting as sort of an Esri shop and then moving to utilizing a lot of open source geospatial software, focusing on building web applications for processing geospatial data. We've always been research focused, so part of our benefit to our employees is a 10% time program where 10% of people's time can be spent towards research in the topic of their choice. And we're always sort of forward looking. We were one of the first people doing distributed computations on Apache Spark with raster data. So looking towards, topics like big data processing. So, computer vision had an explosion in this decade. And so we were definitely keeping track of that and looking at that as a potential avenue to, expand our technology. And so we got a grant from the USDA around tree species identification from leaves. So take pictures of leaves, identify the tree species. And we were able to use those funds to develop a neural network and do a proof of concept that performed really well at that task. Now, those were leaves against a white backdrop. It's a pretty easy task. So once you move to sort of a noisier background, the model started to fail. But
what year was that, Rob? I'm just curious.
I want to say 2015, but that might.
So still pretty early in the days of applying real deep learning methods to any type of image. All right.
Yeah. And then so we, started down this path of developing these models, and realized that this could be applied to overhead imagery. And there was the ISPRS Potsdam data set that we were interested in applying these techniques to. So that is 5 centimeter imagery, I believe, over Potsdam, Germany, that has semantic segmentation masks for 6 different classes. So we put somebody on it. We were like, let's invest a bit and explore what we can come up with. And so an engineer of ours, Louis Fishgold, did a great job. Developed a process of taking the geospatial imagery, cutting it up, feeding in tiles, and doing semantic segmentation using a fully connected neural network that he developed in Keras. And then that was a great proof of concept. So we applied it to that realm as we had time to invest in that technology, and then eventually the Planet Kaggle came around, and we decided, hey, we have this like library of scripts built up to apply to that contest. Let's give that a shot. And then the engineering organization that we are, you do something twice, you start to try to like refactor and, create reusable components. We immediately started saying, okay, as we invest in this competition, we're also going to invest in toolings that will help us in, in other forms of this domain. And that's sort of how Raster Vision came about, is, our library of doing this type of deep learning work on geospatial imagery.
That's awesome. I didn't know that. Yeah, that's really cool.
Yeah, I think Rob's job at Azavea is the VP of Research and Development, and I'm kind of in a sales role, so I sit almost like downstream of him. I think a pattern that we see a lot, you ask, like, how did we get into it? Our core business is building custom software applications for people, but we've always had this part of our mission statement to advance the state of the art in geospatial technology. And so what you see happening over the decades now, which is, we're pretty proud of that, is that the R&D wing will work on something novel that's kind of timely, like part of the hype cycle, more or less. And then 5, 6, 7, 8 years later, that's just a core part of our offering. That's sort of everyone. It's like table stakes to be doing that. And so Rob's initial entry into Azavea was to run a different open source project for distributed raster processing. Now we're building applications for using that same technology for doing all kinds of things like watershed modeling and other types of like large scale raster processing. We don't pitch our clients, hey, we're doing distributed raster processing. Like, no one cares about that, but it enables those types of applications to be built. And I think we're just at the early stages of some of Rob's work around deep learning and his team's work around deep learning transitioning into project work, where our clients don't really care that it's powered by deep learning, but that is like an important part of the project. So yeah, we get into it intentionally, like we're doing machine learning intentionally, but the goal of it is for that not to be a big deal in the long run, that it'll eventually be folded back into our core business of just building custom software applications.
I think that's a cool success story in the sense, Nick and the team and I, we've been at this for a while, as you guys know, and even today, like when we'll be going talking with an end user or a different commercial company, there'll still be people asking, are these technologies legit? Is this worthwhile? And the fact that anything can be transitioned out of a research group into product fairly seamlessly with a happy customer at the end, that's something to be celebrated. And so I don't want to take us too far down a hole on how you guys do that or what the magic sauce is. But, I think one of the things that, and you mentioned this as at your last comment there, Joe, which is customers don't necessarily care, right? They care about the results. And I know one of the things that we've seen a lot in your blogs, we've certainly blogged a lot about this, is the utility of models to actually answer a question. So it's one thing if they perform really well, it's another if they can actually be used. And that's something that we've been spending a lot of time thinking about, whether we're open sourcing data or anything else like that, is how can we get closer to that and desired end state. And so a question, right, and I'll kind of open it up here again, is, where do you see the current state of the art, right? I mean, in terms of deploying models that can answer a customer's question. We spend a lot of time thinking about how the human will annotate like a model or a projection from a model, not necessarily just deriving some answer for whatever the application may be. Like, what do you guys see, and how does that impact kind of where you're at in developing software?
Yeah, we're a couple years into our journey into the realm of deep learning specifically. And we're very much still figuring out where it fits in actually solving real problems or answering real questions. I think one example from our experience that I find kind of illustrative is that we worked with a large water utility who they had this maintenance coordinator named Kenny. And Kenny had like 20 or 30 years of looking at these tanks, water tanks where they stored water, and he could just kind of intuit which ones they should do maintenance on. And so they started to get freaked out because Kenny's getting close to retiring, and he can't articulate what the equation is for how they manage multi-million-dollar budgets every year for painting and maintaining these tanks. So they thought, all right, if we can fly drone imagery around all of our tanks, we can quantify it. They did that. They realized terabytes of drone imagery later, like Kenny doesn't have enough time in the day to look through all this and annotate it. And so they started breaking that problem down into smaller and smaller tasks, which is what we helped them with, which was just like use a machine learning model to detect rust on these sides of these tanks. And then we can take the hundreds, or they're a large company, so they have thousands of tanks. We can rank them from rustiest to least rusty. And then what I love about that story is that model actually was not very useful. And the reason is that surface rust on tanks is not indicative of the health of the tank. But Kenny, that he was like, yeah, that if I knew how rusty they were, that would help me.
So you had buy-in from Kenny early on.
Oh yeah,
Okay.
Kenny's down. But one of the things that we see over and over and over again is that, yeah, maybe someone in corporate will say, we're getting pressure from investors. We need to be doing analytics and machine learning. So bring me a machine learning project. And so that filters down. It eventually gets to someone and they say like, oh, this company can solve this problem for us, this very small thing, and we'll show a proof of concept. It filters back up. They say, great, you were able to detect all the rust. And then they're like, why did you do that? What's the point? And the phase 2 of that project, we built a pretty good rust detector that we were not very proud of. We wanted to like do a second iteration of it, do a semantic segmentation, tell you it's 66.6% rusty. They were like, could you just build us, we're doing all this in an Excel spreadsheet. Could you just build us a tank management application? And I think that's where you get to the value. So I'd say the state of the art is you spend a year or 2 years working on a proof of concept only to learn that you are at the beginning of the work, at the conclusion of that proof of concept. So that now you've got a model that automates some tiny piece of something. Actually, most of the work is building a user experience or a product around a problem area that you're focused on. And so I think the best companies, the best solutions are, it sounds cliched, but like end-to-end solutions. They're products, they're user experiences that may or may not appear to be powered by artificial intelligence. But the way that they bring it to market is about the problem that they're solving. Most of the use of artificial intelligence, at least that I've seen and that we've built as a company, is not answering a question for you. It's providing an input that is part of a set of inputs that may all be machine learning generated or may just be partially machine learning generated so that a human can make a more informed decision. So it's very much like not using artificial intelligence to replace somebody's job, or it's mainly just doing a repetitive, redundant task very, very effectively so that a human can spend their time better on the higher level decision making. That would be my take.
Yeah, for sure. And I think the state of the art, according to kind of the marketing material that a lot of companies will put out, it seems like it's these processes are already automated. We can just like deliver you foundational features from imagery and no problem, they'll be tagged. But really, at least from what I see, is that it's still very much a work in progress, and it's the state of the art is finding that small problem that you can cut off and say, we're going to build a model to solve this very specific problem, and then think, you have to think through how is that going to actually be deployed to serve some purpose. And that's still sort of a manual process. It's really difficult to productize, and pretty hands-on approach. So, but where I see it useful is, things like, if you have a lot of imagery and there's sort of needle in the haystack things, but there's enough needles to be able to train a supervised model on. Now we can curate that imagery to prioritize what you look at, right? But the human's still there. It's just like we're now a better sort function. That's sort of how the rust detection worked, right? Or if you're taking imagery of miles of pipeline, and you want to detect threats to that pipeline, like construction vehicles. If somebody's digging, there can be some pretty awful disasters. How do we automatically take the human out of that loop and automatically detect those types of things so that there can be faster responses, right? Those are where I see models actually being effective and applying to these use cases.
And I feel like that's a perspective. It's great hearing you guys describe this kind of whole process of how you can actually try to find something to cut away and build a model to address, because that kind of perspective isn't something you hear in a lot of places, right? People will say, I want AI to solve my problem. And actually having the insight and the foresight to think about what a problem is that a neural net can actually solve, and then building the model specifically for that application is fantastic. But that also requires a lot of expertise in deep learning, a lot of understanding of what is and isn't possible to get there, right? And so it makes it really hard, I feel like, to integrate this vertically, where you'll have senior leadership who says, we want this problem. Maybe they're excited about using machine learning to try to reduce the amount of employee time on it, but they might not have the perspective to understand what is or isn't really feasible.
I'd say that's the best part of our business and the worst part of our business. The best part being we get introduced to a ton of different companies and different industries, and we get to be consultants to them as they figure that out. The worst part is that if we're ever successful, which is kind of rare actually, that something gets all the way to the point where it's self-sustaining and the company picks it up and runs with it, I feel like, oh man, we just put so much work into this amazingly cool solution to a really hard problem, and now you own it. And now you get to reap the benefits of it. And we got to start from scratch every single project. So it's a double-edged sword, I think. The good thing is that because we see so many different industries, we're able to pattern match across different things and start to see where we can reuse tooling, produce open source tools that make it easier for us to spin up on these projects over and over. But yeah, it is like crushing to me sometimes when we actually have a project that works. And I say actually because a lot of them, we do the proof of concept, we show it, they say that's awesome, and then they say we're really excited about this, we're going to get back to you in 6 months, and that's the last they won't respond to emails after that. It's like they realize, we didn't think through, if we actually solved this problem with machine learning, would it even be valuable once we had that in operation? You see it all the time. And so we probably lose more deals than we win by coaching people out of going through this process, because it's not really lucrative to us as a business to build small prototype projects over and over and over that never get to the point where they're a full-fledged software system. So yeah, it can be fun, but it can also be kind of frustrating, I think.
In that thread, and this is something we've even seen a lot just in our lab, and Nick can certainly speak to this in detail as it relates to our previous work with SpaceNet 4, looking at off-nadir imagery or off-angle imagery, which is, I'm curious, across different industries, how much does customer education, for lack of better words, goes into the upfront process? You alluded to it by walking them through what may be appropriate from a technical perspective. I'm almost thinking one step further back, which is, in the case of the water tank example, do they understand how much imagery they're collecting? Do they care if they're not looking at it? Do they know, right, that they need to be analyzing it at scale? Are they making the cost trade-offs with what it costs to fly and maintain the drones? I mean, we ran into this with people saying, well, why do we care about off-nadir imagery? How much do we collect? Well, there's actually a lot that we do collect that we don't look at. Well, can it be used for machine learning? There was a lot of just business analysis that went in front before we even started talking about what the technical solutions should be. So is that something that's kind of inherent to every project that you guys launch?
Yeah, I think we lean on what I think of as unicorns like Rob a lot, who are engineers who actually do the work day in, day out, and can talk about it with customers. And culturally at Azavea, I think we retain people that have those skills where they can do both. And so we wind up doing a ton of education in the sales process. I think that's like the most fun part of my job, is getting to learn about a new business and then trying to say, look, we actually understand what we can promise and what we can't. And here's what we can promise. It's not actually that exciting when you look at it. You know, it's not like a crazy claim we're making. Is this still worth pursuing to you? And so, I mean, maybe Rob, you can talk about some of the evolution of our thinking around making promises around accuracy, for instance, or like how we educate customers about what they should expect.
Yeah, do they come with you? Like, this is something we hear a lot, right? Do they come with you? I'm curious, with like specific metrics, like, hey, I need it to perform at this level, and can you guys hit it?
Well, they'll say like
yes or no.
95% accuracy, and you're like, what does that mean? You know, here are the different metrics we can evaluate ourselves from. What is the data set you have? What can we hold off, hold out? What is the level? Well, how much training data do I need? Well, that's really specific to the type of thing that you're trying to find. Like how varied and how distinct are the items that you're trying to find? Like, what are the classes? So it is like every time a very consultative process, and it usually is across like different industries. Like, for example, like talking to somebody from the medical imagery, which is very similar to satellite imagery, like finding things in satellite imagery. But it's like, okay, well, we have this many slides and this type of a phenotype, and it's like, okay, well, that's really like I can't see it and see a difference. Maybe like you're a trained medical professional, you can really see that difference amongst the classes. So a lot of times it's like we would have to try to create a model and try to see what's possible in like a small prototype, because that's the only way to like really find out. But in that way we don't make like specific promises about accuracy, because it's just like so varied across so many different use cases. Where so like, here's the state of the art, here are examples of what people are currently doing. This is how we see this is closest to what you're trying to do. And so we can expect to get those types of level accuracy if the data is the data that you say you have. Because a lot of times it's, people say, oh, I have, all this labeled data, and it's like, actually you don't. So that's like a whole other project to say, okay, if you need us to go through the data and annotate it properly.
I was going to ask, do you guys do that? Because we can tell you, obviously we can tell a lot of horror stories about that whole experience.
Yeah, we do. And it's hard to make it's easy to make assumptions about data sets, and you say, okay, this person said this and this is what it is. And then until you like look at it, you just don't know. And then so that usually snowballs into, okay, we actually have a process of, we built an in-house tool we call Annotate, very cleverly.
Yeah, I like it.
It's a great name.
I've never guessed what it does.
So that we can load up imagery through Raster Foundry and serve out and sort of like tasking manager type squares, and have labelers label it and then do a validation pass. And so we're really confident in that process. We have somebody managing it and doing QA on various parts of it and do training. So if we can go through that process, we're very confident in what we can produce there. But then anything else in the wild is like, you can't make assumptions about. So the model's going to severely underperform if that's off. So it's just kind of like, you really have to define a starting point. And even when you define the starting point, the reality of the situation might not match. And then so we just try to set expectations based on all of those like caveats. And that's the reality of the situation. So we're, it might lose us some sales, but at least we're starting a project with like full knowledge of what the capabilities are and what the potential outcomes are.
Do you guys ever tell customers, like, I'm just curious, because we try to be as meticulous as we can about data sets, and anyone who's followed sort of our blog or Nick's blog series is just us going into probably the minutia, right, of just one data type. In our case, I'm thinking of building footprints, Nick, and you can certainly jump into that. And it'd be hard for, I think, I'll speak for myself, just to step out of that and say, hey, here's some random data. We can run some model, try to benchmark it, but we have no idea the quality. Do you guys just sometimes say like, hey, we can't use any of this? Like we have to move on, or we're going to have to relabel it if in the case or in the event that it doesn't meet the standard that you would need for a machine learning project?
That's a great question. I think I wish we had that problem. Like, as in your supposition, people come to us already with training data, not just an idea that they like had in the middle of the night. They're like, hey, could we do a model that does this? Oh, I've already spent the time to collect imagery for it and have people annotate it. There are the rare exceptions to that. I'd say there's two main categories where we're not doing annotation ourselves. The first is we're combining open data sets with each other, and all the caveats that come along with that. So if you take extracts from OpenStreetMap, and Rob can talk about this, you can export OpenStreetMap data, you can layer on timely imagery underneath of that, and you can start to generate models. You can basically leverage a huge annotated data set. It's not as pristine as something that you actually labeled from the imagery. That would be like one category. The other category is rarely, but occasionally, a more technical company. Like we did a project for a drone startup, like a well-funded sort of Valley drone startup that is really forward thinking about trying to maybe open up some of their data that they've collected. And we're like, yeah, do that. Definitely. Maybe run a competition. We're trying to encourage it. And when we actually did the work to build the benchmarks for them, that's what the project was, is like we could either spin up two ML engineers in the Bay Area for $300,000 a year each, fully loaded, and have them spend 6 months on this project, or we could hire Azavea and you could give us something well documented quickly, because you do this type of like ad hoc work. That's our specialty. And so we did a month-long project. We trained probably like 15 different models, different experiments, tried to benchmark them, tried to show what was significant in actually moving the needle on the accuracy, what they could expect if they ran a competition, being able to release code and open source models alongside of that to say, hey, why don't you start with this as an idea or beat this? And what we found is that data was pretty well annotated. I mean, it was semantic segmentation data, so it's like the hardest kind of data to annotate. But you could see the seams where they had chopped up this drone imagery into chips. And like if you're zoomed in on a green, like a golf course green, are you looking at the middle of a green pond? Or are you looking at a flat grassy area? Like it is in isolation without spatial context, really hard to know the difference. And so we had to do all sorts of compensation for this poorly labeled, seamy data. And that's, I think, it made us feel a little less stressed out about investing so much in our own annotation tool, which is it provides spatial context, like it's built for geospatial imagery. So you can get past some of those same limitations where these companies have built these really impressive systems, but they're assuming you're annotating Facebook images. And so, yeah, we've never had a case where someone brought us data and we said we have to throw it out completely. But absolutely, I would say that way more often than not, we are manually annotating, even if we're starting with a data set that someone has provided us.
Yeah, I'll say there's one case where it almost got thrown out because it was that bad, but then we just did the work to go in and fix all the labels. Because especially in instances where things are not exhaustively labeled and you need that exhaustive labeling, or you're doing negative samples in areas that have positive instances, it kind of takes doing the work of going in. And luckily enough, it was a small enough data set that didn't take too long. But yeah, but I don't think there's ever been an instance of us like turning away a customer because their data was too messy.
That's my new goal. for the next 6 months, I want to turn away at least.
Is that a win for this podcast? Maybe no. But I think for those who maybe aren't as familiar with the geospatial market or technologies, I know I'm not a native geospatial person by training. I've only really been in it for the last 6 years, and Nick can speak this a lot better than myself, so I kind of let him do it. But I mean, just on the amount of complexity that goes into figuring out how to tile an image or tile scenes, break it out, feed it into a model, it is something that we find is a topic that we have to talk about constantly. And even just with the most recent challenge that we're hosting right now, I mean, that was a major discussion that we had internally, was how to chip out the data, what chips are included, what type of spatial contacts exist, all that sort of stuff. So
Yeah, making sure that you can get as consistent sampling as you can between the different parts of the data set, the training set, the part you're holding out, all that kind of thing is extremely challenging. Figuring out how to tile the imagery down to an appropriate size that you can, work with it within a model, but also still having the flexibility to ingest chips of different sizes in the model, because a lot of models will take different size pieces. I mean, these are all major software engineering challenges that come with trying to squeeze geospatial data into deep learning models. And yeah, we certainly hear you on that. And I got to say, the work that Azavea has done on looking at the importance of label quality and where that threshold really is for how well labeled something needs to be is really, really useful. And any listener who isn't familiar with it should check out some of their recent blog posts on this, because this was literally an experiment that we were sitting in the office talking about doing, and then I read it on Azavea's blog.
Nick sent it out on Slack. We're like, all right, we don't have to do that one.
Yeah.
Thanks.
And along with that, my colleague, data scientist Daniel Hogan's work on how much imagery you need and for model training, all this kind of stuff. It's all geospatial specific in some ways, and that and it's important to have this context around your problem.
I think it's funny that you said I'm not a native geospatial person. I mean, Nick, you have
I have like 1 year of geospatial experience, so I'm not sure if
it's a deep 1 year though.
It was,
I mean, before this job, Rob was working in a ball bearing factory in Baltimore, so
well before this job, but I was counting ball bearings. That is true. Yeah.
I think the funny thing about the geospatial industry, I'm super skeptical of anyone that doesn't say they're a transplant from somewhere else, because I mean, why do you care about geospatial specific? Like Rob talks about this all the time. It's a horizontal field that can be applied in many vertical ways, and people find it through those vertices. And so the thing that is I guess fulfilling about our work is that ideally our users are not geospatial people. So the people that come and use the Raster Vision open source project that we've built, the whole idea is making it easy to apply these same familiar computer vision methods to geospatial data, which is super cranky and super weird.
That's the better adjective as opposed to just saying awful, which is normally what we say.
But that's huge, though, because at the moment, if you want to do geospatial computer vision stuff, you need to be an expert in coordinate reference systems and geospatial transforms and dealing with large format vector labels and imagery, as well as all the computer vision stuff. And so tools like Raster Vision and our tool Solaris hopefully will make it a lot easier and enable a lot more research to get done in this field.
Completely.
So it's a good pivot point. So you guys have laid a foundation. You can now hopefully jump across a lot of different verticals. You have your annotation tools, and you have some success stories as well. And I'm really curious, and this is something Nick and I were talking about in preparation for this. So where do you see things going next? Like a lot of times, like we're now hearing, like whether it's in blogs or whatever the case may be, there's certainly an emphasis on data sets and data quality, but it's more than that. And I'm curious, where do you guys see things going from a deployment perspective in either some of your existing customers or things as we look out, getting closer to either full automation in certain applications? What are your guys' takes on that, from everything from data sets to models to customer adoption? Just curious.
Yeah, it's a pretty long pipeline. So from the data set side, I think that seeing things sort of converge on a set of standards, the spatiotemporal asset catalog work that's being done, I think that will continue to lay a foundation of sharing this type of data and being able to work with it. The ARD stuff, analysis ready data sets stuff, isn't as far along as Stack, but hopefully it takes off in the next couple of years, so that there can just be some consistency on the input side. As data quality improves and the availability of more and more training data produces better and better models. And then as far as, model deployment goes, it's the question of having a model that performs really well at a task is great. It's awesome. But how do you leverage that? What are the ways that users can actually take advantage of that model output? And that's kind of an unsolved thing in our space, I think. Like there's some low hanging fruit, like, Hot is doing the sort of complexity of tasks. How do we like break down a task into less complex tasking manager squares so that mappers can, get the appropriate task size for an area, whether it be dense or rural. And, that's been an idea that's been around for a while. And there's models, I think, that can do that type of task. But that tool does not show, I'm not using that tool currently. If I go on tasking manager, it's more of the implementation side of okay, we've done proof of concept model building. How do we deploy these things in a way that is effective? Also, there's all the ethical questions of how are deployed models once they're actually being used. What are the sort of dangers of relying on a model output for doing things like mapping certain areas over other areas, right? There's a lot of conversation right now around the ethics of utilizing models. So I think that'll also be playing out heavily over the next couple of years. But yeah, as we see these models being more effective, being proven out, what are the systems which utilize these models? And kind of what Joe was talking about, where if there's a user using a system that's using AI effectively, should that user even know that AI is being utilized? Why is that sort of the selling point? It's really, does this solve your problem? So using models and deploying them to solve problems is sort of the next step in this sort of wave.
It's so sad. It's so sad. They're like, the future of machine learning is that we're going to start solving problems. Yeah. I wish I didn't agree with you so much. I think your question is what's next in machine learning, and Rob gave you a good technical roadmap for I think what engineers are going to be focused on next. I think from a sort of industry macro perspective, I'm going to make some predictions that I'll regret a few years down the line, but
don't worry, this is only recorded on the internet forever. So
yeah,
there's no way everyone on the planet can find it. No, go ahead.
I gotta plant my flag here and
it'll
say
be better than your Twitter takes about coffee.
Oh yeah,
yeah. We're going to talk about that later.
Yeah, I've been cautioned away from Twitter so many times now that I'm just fully committed to using it every single day. No, I think, and I've talked about this on Twitter, not that anyone cares, but in fact, very few people care. But I think
Nick and I like this.
Yeah,
so we care.
Okay, good. Thanks. I needed that. I think 2014, 2015, 2016, there was hundreds of millions of dollars of venture investment in this space. Companies like Orbital Insight and Descartes Labs, which raised pretty phenomenal sums of money, which haven't raised money in the last 2 or 3 years. I think they will either raise again and they'll sort of extend that runway, or they'll be acquired in air quotes because we're all still searching for the killer application, and you can only do R&D so long. So I see a massive capitulation of companies in this space. I think there will be some really big companies that come out of this period, and we're kind of living in the golden age. All that venture investment has turned into an amazing, an abundance of open source tools and collaboration, data sets like the stuff that SpaceNet puts out. If we had SpaceNet when we started, and the years of it that have gone on, all the data that's been accumulated, there's no excuse anymore. You don't have an excuse. You have amazing curated data sets to start with. There are going to be really great companies that come out of this, but the speculation that happened 3, 4, 5 years ago that created this boom, I think patience is running out. And so I think over the next 2 or 3 years, I would expect to see a lot of companies get acqui-hired or acquired or whatever you want to call it, or some of them are going to go to zero. Like in the drone space, a bunch of the biggest companies that have raised the most money have gone to zero, like actually just fire sale, which is amazing to me. And it makes me feel fortunate that we never did raise money, that we've kind of taken it stepwise. We've felt self-conscious for many years. Like there's not that much demand for this. Like our team isn't growing that fast. Like our business isn't in this space isn't growing that fast. But now I feel actually kind of happy about that, because I think there will be a long, slow adoption of these tools that won't be as exciting or sort of PR driven, but that's going to create a ton of value. And if you are lucky enough to be a company that sticks it out, there's going to be a lot of value to be created and a lot of money to be made. So that's what I would expect to see over the course of the next 2 to 3 years. Although I probably would have predicted that like 2 years ago. I would have said the same thing, like, oh, it's like we're at the peak of inflated expectations. So who knows? Maybe 2 or 3 years from now, we're in the same place we are now. But I would be surprised if that happened.
I think the to extend that though, I think the one area that I'm certainly surprised about is simply if you look at just the performance of models over time, and we say this a lot, but it's been great and it's been rough. And in some ways, like if you look at certain cities in the SpaceNet data set, we've seen pretty strong performance that's now sort of at a sort of an asymptote level. But in other areas, there's still like kind of core questions that R&D or applied R&D really haven't scratched at yet that are pretty key. So like looking at different geographic diversity, I mean, we're not the only ones obviously focused on this. A lot of groups are. I know when we were looking at what cities to add, we were talking about this with all the partners. There's a big focus on saying, we haven't seen as great performance in some like emerging market areas or unique cities. Like we need to get them more involved because that's where a lot of interest is. And we're not seeing a lot of models that are really well tuned or suited for that, Nick. I know this is something we talk about constantly.
Yeah, absolutely. I mean, the inability of a lot of the state-of-the-art models that we work with to generalize to anything, any geography that they've never seen before, even a slight change in lighting conditions, in the look angle of the satellite, this kind of thing, it's a major problem in terms of trying to deploy something for a very generalized product that you want to work worldwide, and maybe for finer use cases where you're not expecting a lot of drift of your data set over time, or where you think you've got a pretty good picture of what your data is going to look like that the thing's going to be applied for, then great. But that's part of the reason we added Moscow, which is covered in snow, in the collect that we have in the current SpaceNet challenge. It's going
to be a rough
totally different from anything that we've dealt with before. Yeah.
Yeah, and that's kind of a good question of, should we be looking for that general model that applies to all of these use cases, right? Or is the value in being able to build many models for specific use cases? And I think we as an organization have gravitated towards the custom built model for the custom application, because that seems like a more tractable problem. If there is a data set and there's a sort of low hanging fruit task that needs to happen to it, and it looks the same across the data set, we can build a model for that, right? So what are the ways that we can build models more quickly using transfer learning, using open source tools to really quickly build and deploy models that will solve that problem, instead of relying on a bigger, better model that will take into account that additional context? Because we've seen generalization as like a big problem, and I think it's a question of like, should that be the goal? Should we have a model that fits everywhere, or should there be many models that fits to certain locations, right?
I think that's just one small note. That's what I find so exciting about stuff like Solaris and raster vision, is that you have a bunch of Americans making deep learning models that work well over America. A lot of the areas that we care about mapping are not in America. They're in Africa. They're all over the world, South America. I think what the biggest value that you're providing is that some very talented engineer in Africa or in Latin America that sees that problem on a daily basis will be able to have a leg up in solving that problem for themselves. And yeah, like Rob, like you said, that model may not generalize back to the United States, but they're solving the problem that's at hand and that they have like special insight about to be able to solve. I don't think it would be as easy for that to transpire. I think it still would eventually happen, but it wouldn't be as easy if everyone took the stance of we're going to keep this proprietary. We're going to make a product that everybody's going to end up using. It wouldn't happen.
So sort of concluding thought here, guys. We mentioned your blog a few times. You guys are really active on that. Got anything else major coming up? Any conferences? Anything we should be aware of? Any product releases? Or just tweets from you, Joe? Anything that's good.
Yeah, no one looks forward to those.
I did after the coffee one. I had to tune you out for a little bit. But I'm back. I'm back now.
Yeah. Stuff to look forward to. I mean, honestly, and Rob, I'm curious to hear what you're going to say. For the past 6 months, we've been so heads down trying to do good work for the client projects that we've won that we've done some research and published it. Rob helped put together the open source fellowship program where we had a graduate student come for the summer, do some research that got published on the blog that Nick, you referenced earlier. That was really exciting. Right now, though, I mean, one of the things that we're looking at is how do we take these tools that we built for ourselves internally, like the annotation tool, like some of the visualization tools we've built so that you can visually check the output of data and open those up to a broader audience. So I think over time, I don't know if that's going to happen in 3 months and 6 months and 12 months, but I think over time I would look to starting to take some of these tools that we've finally proven out with our own processes and start to open those up to a broader audience. That's something that I think you can expect to see from us.
Yeah, and some other things to note. We've been working with a group called Driven Data on a couple machine learning challenges. One involving the World Bank for building footprint segmentation off of high-resolution drone imagery. And then also a Caribbean data set that is more about, it's a really interesting problem. It's around, we basically give the building footprint, but you have to classify the roof material. So that's a kind of a different take on this sort of building classification problem. So we're going to those are going to be launching over the fall, and then we're going to be participating in the Stack working group session that's upcoming. I think you would know
Nick,
more about
it's
that.
Going to be at our house.
Yeah,
that's
it's
right.
right there.
Yeah,
home field advantage.
Yeah, so we're excited to help out with that and kind of move that standard along because I think that's really important work.
Well, guys, this was awesome. I really appreciate it. Nick, just if you want to give a quick plug on the Stack sprint, since we've been mentioning that a few times.
Yeah, absolutely. So Stack, the Spatiotemporal Asset Catalog, is a specification for how to build a catalog of spatiotemporal assets or overhead imagery primarily, although it's being extended to other modalities such as vector labels for data. There have been a series of sprints that the Stack organization has run to try to make progress on iterating on this catalog, which is still being developed and very, very actively being worked on to try to make sure it fits all of the needs of the community while still remaining fairly simple and flexible enough to accommodate new things as they come along. And so we will be hosting a 3-day sprint to work on that, mostly working on the API for accessing Stack catalogs and data sets that people have made, and that will be in partnership with OGC.
When will this exciting event occur, Nick?
Very beginning of November 3rd through 5th.
Excellent. And for all those listening, we'll make sure to have both the link up to Azavea's website and their blog, as well as the information on the Stack 5 sprint. So just make sure to see all that in the details. And with that, guys, keep up the great work. Thanks for coming in.
Thank you so much.